let's take a look at your 6.6 assignment here on linear programming. Now, remember with linear programming, we got a lot of different steps we need to do to solve this problem. So as we always advise you to do, first things first, read the problem. And when you read the problem, our first step is to define the variables that we're trying to solve for. So, number one here says a clothing manufacturer makes pants and shirts. Both pants and shirts require the work of sewers and cutters. There are 60 minutes of sewing time and 48 minutes of cutter time available. It takes 8 minutes to sew one pair of pants and 4 minutes to sew one shirt. Cutters take 4 minutes on pants and 8 minutes on shirts. The profit on a pair of pants is $2 and on a shirt is $1.50. Find the maximum profit and the amount of pants and jackets to maximize the profit. All right, so usually the last sentence in the problem tells you what variables you need to define. So I'm going to let x equal the number of pants we're going to make, and I'm going to let y equal the number of jackets. We are also trying to maximize profit, so I'm going to let P equal profit. So we actually have step one taken care of. Step two then says, if you remember, write our objective function. What's our goal? What's our objective? Function, remember, is an equation. So we're trying to maximize our profit. So I like to say max P, and how do we make money? Well, according to our information right here, the profit on a pair of pants is $2. So it's 2 times x. Since x represents the number of pants, 2 times the number of pants, plus $1.50 times the number of jackets, which is our y value. So we have our variables, we have our objective function. Next up comes our constraints. So when we talk about our constraints, we're talking about what's stopping us from making thousands of pairs of pants and thousands and thousands of pairs of jackets, or I shouldn't say pairs, but thousands and thousands of jackets each and every day. Well, if you look at it, there's constraints on sewing time. So there's only 60 minutes of sewing time and 48 minutes of cutter time available. So we're going to talk about how much it takes for each of these. So I'm going to start with sewing at a maximum of 60. So the time I use has to be less than or equal to 60 minutes. So it takes 8 minutes to sew one pair of pants. So 8x plus, and then if I take a look here, cutters take 4 minutes. Oops, I apologize, I gotta stick with the sewing. 4 minutes to sew one shirt, and really that should say jacket. So I apologize for that. Shirt and jacket are one and the same in this problem, so that's going to be 4y. Then we're going to talk about cutters. Cutters only take 4 minutes on a pair of pants, 4x, and they take 8 minutes on a jacket, 8y. That has to be less than or equal to the 48 minutes of time the cutter has. Now, the other two constraints that we have to take into account is that you can't have negative jackets and negative pants. So x has to be less than or equal to 0, y has to be less than or equal to 0. So because they have to be positive, I can go ahead right now, label my x-axis pants, label my y-axis jackets, and now I'm going to want to graph them. I apologize, I'm going to move this because I want to use that space right there here. So I'm just going to put jackets up here. So now, I want to graph all of these. I know first and foremost, because of these two values, my quadrant, or I'm in the first quadrant. So I know that y has to be greater than 0, x has to be greater than or 0. So I know that I'm going in this direction and this direction. Now I'm not going to do any shading until the very, very end. Next up, I'm going to graph the constraints by finding their x and y intercepts. So on the first one, what I like to do is I like to let x equal 0 and then solve for y. Let y equal 0. So what I do is I cover this 8x up because 8 times 0 is 0. So I'm asking myself how many 4s go into 60, and that is 15. Then I ask myself then, if y is 0, I just have 8x is less than or equal to 60. So I ask how many 8s go into 60, and I believe that is 7.5. Do the same thing going so I'm going to take, or I'm going to get the other y-intercepts. I'll do a different color here. I'm going to let x equal 0. So I ask myself, again, how many 8s go into 48? And that is 6. And then I'm going to see how many 4s go into 48, and that is 12. So now, when I look at this and I start to scale it, I can see that my biggest number here on the y is 15. For the x, it's 12. So depending on how you want to scale and how big you want to get, I might actually, since here I really can't count by ones because I believe my grid is like 10 by 10, I might count by, in this case, 2s. So let me go back here to my different color. Go 2, 4, 6, 8, 10, 12, 14, 16. That should be enough. 2, 4, 6, 8, 10, 12, 14, 16. So to graph the purple line, I'm graphing the point 0, 15 and 7.50. So really, basically what I'm doing roughly is then drawing these, connecting these 2 points the best I can. I get my line, and then my shading, since it's a less than, is going to be below. So right now my solution is this triangle. Then I'm going to graph the line in green. So I'm looking at 0, 6 and 12, 0. So if I look at that one there, I'm here, here, boom. And now my shading, again, less than means below. You can see where all my arrows are pointing. So here is my feasible region. So now, what I need to then do is find all of my corner points. So I have my graph. Time to figure out the corner points. So, switch to blue, different color here. Hopefully it registered blue, yep. So now we do the corner points. 3 of the corner points are pretty easy because you can read them right from the graph. So this one's at 0, 0. This one up here is at 0, 6. This one here is at 7.50. And then we need to figure out this one right here. Well, that's the intersection of my 2 constraints. So as we saw a couple of units ago, we could use matrices to figure this one out because it's the intersection of those 2 inequalities or those 2 lines. So if I use matrices, I can go 8, 4, 4, 8, xy equals 60, 48. So I'm going to enter this as my A matrix, enter this in as my B matrix, then I'll go x equals A inverse B, and I'll get what x equals. So take out my calculator, go to my matrix menu, I'm going to go over to edit, I'm going to change it to a 2 by 2 matrix, and then I'm going to enter in 8, 4, 4, 8. So go ahead and exit out, go back to the matrix menu, let's go over to matrix B, whoops, sorry, forgot to go down one to matrix B, 2 by 1, we're going to make that 60 and 48. So now I can go matrix A inverse times matrix B. Now give me my intersection point of 6, 3. So this actually intersects, if it was drawn a little bit better, would have been over just a little bit more. 6, 3 seems to make pretty decent sense there. So my last point intersected at 6, 3. So now, once I have my corner points, just got a couple more things to do. So I'm going to take my objective function, and again, my objective function, if I look back up here, is this 2x plus 1.5y. So p equals 2x plus 1.50y. I'm going to plug in all of these values to solve for the profit. Now, I know this first one, I always just tend to show the work, but I know if I don't make any product in this case, I'm not going to make any profit. On the next one, I'm not making any pants, but I'm making 6 jackets. That's going to give me a profit of $9. On the next one, 2 times 7.5 plus 1.5 times 0, that's going to give me a profit of 15. So we're going to see if this last one does even better for us. And sure enough, I believe this one gives us $16.50. So we're trying to maximize it. So that's our biggest value. So of course, the last and certainly not least thing we need to do is answer it in a question. Or sorry, answer the question in a sentence. So we should make 6 pants and 3 jackets for a max profit of $16.50. All right, so that takes care of the front side. Let's take a look at the second one on the back side. Same type of problem, just different, context here. It says Super Bats Inc. manufactures 2 different quality wood baseball bats, the wall banger and the dingbat. The wall banger takes 8 hours to trim and turn on a lathe and 2 hours to finish it. It has a profit of $17. The dingbat takes 5 hours to trim and turn on a lathe and 5 hours to finish, but its profit is $29. The total time per day available for trimming and lathing is 80 hours and for finishing is 50 hours. How many wall bangers and dingbats should Super Bats Inc. produce in order to maximize their profits? What is the maximum profit? So again, this last couple sentences helps you define what your variable should be. So I'm going to let x equal the number of wall bangers. I'm going to let y equal the number of dingbats. P is going to equal our profit. So now, our objective function. Going a little bit faster here. what is our goal? We're trying to maximize profit. So our max profit equals, well, according to the information, we make $17 profit on a wall banger, so 17x, and we make $29 profit on a dingbat, 29y. So now the question becomes, what's stopping us from making infinite amount of baseball bats? Our constraints. Okay. So, I know some of you like to right away just say, all right, well, I can't make negative bats, so x and y have to be greater than or equal to 0. If you prefer to start with those two, by all means. Now, our other constraints deal with time making them. So according to our information, okay, it says the total available time for trimming and lathing is 80 hours. So something has to be less than or equal to 80 hours. Well, how much time does it take to trim and trim and turn on a lathe for these bats? Wall bangers take 8 hours, okay, while a dingbat takes 5 hours. So we'll have 8x plus 5y has to be less than or equal to 80. Now the other one is finishing. To finish a bat, we only have 50 hours. According to our information, it only takes 2 hours to finish a wall banger, but it takes 5 hours, okay, to finish a dingbat. So 2x plus 5y has to be less than or equal to 50. So again, when I'm graphing this, I know here's my x, here's my y. I know I have to be both in positive. Here's my wall bangers. Here's my dingbats. So now, just like we did before, I'm going to let x equals 0, solve for y. I'm going to let y equal 0 and solve for x. So if I let x equals 0, how many 5s go into 80? Just to save you a little time, it's 16. Then I say, all right, if y is 0, how many 8s go into 80? That is 10. Do the same thing for the other one. I'm going to let x equal 0. How many 5s go into 50? That's 10. And then I say if y is 0, how many 2s go into 50? That's 25. So now when I look at this, I might be thinking a little bit more when I'm counting and spreading out here, because I have to go all the way up to 25. So I might count by 3s here. I go 3, 6, 9, 12, 15, 18, 21, 24, 27. Do the same thing going up. 3, 6, 9, 12, 15, 18. I don't think I actually have to go any farther than that. Sorry about the jump there. So, because I think my highest y value is 16. That's where I'm going to start. 0, 16, and 10, 0. Connect those two. No, my shading is less than, so it's going to be below. And then 0, 10. And then 25, 0. Connect those two the best I can. No, my shading has to be below. So my feasible region is this area right in here. So I have 1, 2, 3, 4 corner points. So now I need to find those corner points. So my corner points, I already know 3 of them pretty easily. 0, 0. This one up here is at 0, 9. This one down here is at 10, 0. Again, the reason why I know those right away is they're my x and y intercepts here. Now the last one, again, is the intersection between my two inequalities. So I'm going to use matrices to solve these. So 8525 times xy equals 8050. So I'm going to go A inverse B to get my x matrix. That's going to tell me what xy is equal to. So let's enter those in. So go back to my matrix menu, go over to edit. Let's change that 2 by 2. Instead of it being 8, 4, it's 8, 5, 2, 5. Exit out. Let's go back to our matrix menu and go to matrix B. Change this one now to, instead of 60, 48, it's 80, 50. Go ahead and exit. A inverse B. And we get our intersection point 5, 8. So this is intersecting at 5, 8. I'm going to look at that. If I go 5 up to about 8, that looks about right. And now I have my points. Now we just need to plug it into our objective function, which was 17x plus 29y, I believe. Let's just double check that. Yes. All right, so on the first one, that one's the easy one. Anything times 0 plus anything times 0 is still 0. On the next one, 17 times 0 plus 29 times 9 equals, well, quick 29 times 9, $261. Nice. Next one, 17 times 10 plus 29 times 0. Well, that's only $170. The last one, 17 times 5 plus 29 times 8. Well, let's see if this one gives us our max. I'm thinking it does. 17 times 5 plus 29 times 8, 317. So this is the one that maximizes our profit. We just need to answer the question in a sentence. So we will say, we should make 5 wall banger bats and 8 dingbats to max our profit at $317. All right, that ends the worksheet.